talking about the eye, there's the physics part, which is the wavelengths of light that go in. But there's also the biology parts, how the different structures have evolved over time to be useful to us. Right? So to help start us off here, do you remember in the video when he was talking about how there was originally a dimple that started forming on the eyes of the flattener? And eventually that dimple evolves into a socket with a hole in the front. So we're going to call that shape the sclera. Sclera. Now, if you've watched a horror movie where they have like someone's eyeball is like ripped from their head, the white, tough tissue on the outside of the eye is the sclera. And its job is to do protection. It's going to keep all these fluids and little tiny moving muscles on the inside of the eye safe. It's that white tissue on the outside of the eye. The other part of your eye that does protection is called the cornea. And this one actually does two jobs. The cornea is there for both protection and focusing. You can actually feel your cornea. So to feel your cornea, what I want you to do is rest your fingers lightly on the tops of your eyes, just like this. And then look left and right. Do you feel it? So rest your fingers lightly on top of your eyes and look left and right. And what do you feel?
All right.
So you should feel this like bump in your eye. It's not a smooth circle. That bump in your eye is called the cornea. It's a lot tougher than the inside parts of your eye because it's going to provide protection. And for focusing, what type of lens is that? Convex. And so convex, is that going to converge the light or diverge the light? Converge. It's going to send the light together to form real images, which is what we want. Okay, so then the light actually needs to go into the eye. So this is all keeping the eye safe. Then the light has to actually get into the eye, and it's going to get in through a hole. That hole looks black, not because it's physically black, like this pen is black. That's a hole that looks black because any light that goes into your eye doesn't come back out. Right? So the thing that you call, it's like a black hole. The thing that we call the pupil, if you did a dissection of the eye, you can't take the pupil and stick it on the desk because that's not a physical thing. The pupil is a hole in the eye, and it's a hole whose job is to let in light. So the pupils are like little tiny holes. So when you look like deeply into someone's eyes and the pupils are like changing size, that's just a hole that's letting in more or less light. Okay. So the black part of your eye, you couldn't like cut it out and remove.
But it doesn't go in when I touch it.
Because your cornea is there, because your cornea protects it. All right, so then we're gonna make this a green-eyed person. All right, so then we have the iris. The iris's job is actually a muscle. The iris's job is to be a muscle. Its job is to open and close the pupil. The iris, as it moves back and forth, adjusts the size of the pupil. And that's kind of why if you look really closely at somebody's iris, you'll see strands because they're muscles. They can move and pull, right? So the iris is this muscle, right, that opens and closes the pupil.
Does it stretch?
So far, if we were like tracking the light goes in, it bends a little bit to get through the cornea. The cornea does a little bit of the focusing. But if you notice, this doesn't really like form an image yet. We want it to form an image. So once the light goes past there, we need to focus it a little bit more. So then, and they talk about this in the video, They evolved a lens, an extra lens. There's actually two lenses in the eye then. The cornea acts at one, and the crystalline lens acts as the other. So you're gonna see me just write this as crystalline lens here, but in other places, I'm gonna be lazy and just call it the lens, because otherwise, crystalline, big word, extra word to write. The crystalline lens is a flexible lens on the inner part of the eye. And because it's flexible, it has an adjustable focal length. Now, when you guys the other day were making projector, right? You were like moving that you were moving your lens. You were moving it in and out in order to make the images come into focus, right? So your eye needs to do that too. When your eye does this, instead of like moving the lens in and out, because that's not really practical, what it does is your crystalline lens is actually really similar in both index and refraction and, I guess, flexibility. The crystalline lens is actually very similar to an Orbi. So you know how if you squish the Orbi, you can change the image that you're seeing? Right? That's actually what it does on the inside of your eye with your crystalline lens. Your crystalline lens is squishy and flexible, and it changes its focal length. The muscles that do that, where's red? There we go. These muscles are called the ciliary muscles. And you can feel the ciliary muscles work. So these are my ciliary muscles. You know when you were looking at your fingertips and you moved them far and close to your face, right? Those are your ciliary muscles changing the focal length of your lens. So their job is to flex and relax. And when the ciliary muscles flex and relax, they, I guess we'll say they stretch the lens to change its focal length. It's going to do the job of focusing the light. So let's make this light focus then. If I look at my picture, now the light, when it hits the inside of this lens, is going to focus even harder. It's going to bend more. Sorry, my picture's awful. And because both the cornea and the lens are converging rays, they're both converging lenses, we get an image that's inverted and real. Imagine if this were a person I was looking at. Then on the back of my eye, I get an inverted, smaller, real image. So now that I've got the light going in, it crosses to make that real image. Now I just need something to pick up that image. So on the back of your eye, you have what's called the retina. It's this film on the back of your eye. And it's a film covered with a special type of cell called a photoreceptor. So I guess retina will put in as a definition, this is a film of photoreceptors. Those are a special type of cell that pick up light and send chemical signals to the brain. Those cells are called rods and cones, and we'll talk about them more later. Rods and cones are our photoreceptors. When they get hit with light, they make electrical chemical impulses that get sent up to your brain. And your brain processes and does the rest. So I think we've got three more. We've got our optic nerve, which takes this signal up to the brain. But notice that your optic nerve connects to the back of your retina. At that junction point, something funky happens. It doesn't have any photoreceptors where that nerve is. Right? Where that nerve is, it only has like a connector, like a disc to help hold it in place. This thing, the optic disc, is what connects the optic nerve to the back of the retina. But the drawback to that is it doesn't have any photoreceptors. So even when light falls on it, it doesn't come up with a signal. The optic nerve or the optic disc where it's connected here, that actually causes something funky in your vision called a blind spot. And everybody has at least 2 of them, 1 in each eye. The optic disc is where the nerve connects to the retina, but it has no photoreceptors. Which means even if light falls on it, you don't get a signal. And in a minute, you and I are gonna find our blind spots. We're gonna go find them. They're tricky, right? Because when you look around the room, do you see any blind spots? Like spots that when you look at, you can't see them? You can if you close one eye. But even if you close one eye, right? There's a trick to it because your brain is so good at discerning patterns. There's a trick. You have to try really hard to find where your blind spot is, but we'll try it in a sec. Last one then, which we'll talk about more maybe later today, maybe tomorrow, depending on our pace. The last one is the phobia. And the phobia is a special spot on the retina that has a super high concentration of cone cells. The phobia has a high concentration of photoreceptors. And that's where our vision is most sensitive. When you're focusing on something, like you're focusing on looking at your fingerprints, you're using all photoreceptors in your phobia to see those. Your peripheral vision comes from the outside parts of your retina. The phobia has a high concentration of specifically cone cells that allow you to see color vision and detail very clearly. So for your test, I would think that these up here are probably the only ones you need to know. If you start looking online though, like depending on the thing you find online, you might find many more parts of the eye that an optometrist would need to know. These are the ones I think we need to know. So the 2 accommodations you need to know. You need to know that in order to focus your eyes, the ciliary muscles are going to change the shape of your lens. And you can actually feel your eyes do this. So what you can do to see how the eye focuses. If you take your finger and you put it way out in front of your eyes, I want you to try and look at your fingerprint.
My what?
Fingerprint. All right, see if you can see it. Since your fingerprints are far from your eyes right now, your ciliary muscles don't have to work terribly hard to focus the light. But now slowly bring that in towards your eyes. At some point, even though you're going to focus as hard as you can, that image is going to blur. Do you feel that? Yeah. What it's basically doing is your ciliary muscles are pulling really hard on your lens, but our eyes, now that we're not animals that live in the water anymore, our eyes, once they pass a certain point, can't see detail anymore. In fact, if you ever put something right at your eyelashes, right, you can kind of see the color, but no details whatsoever. That's because when humans, our early ancestors left the water, our eyes are no longer adapted perfectly. And since it's been hundreds of millions of years now, we haven't really adjusted to that fully. So we don't see in HD right in front of our own eyes. Your parents need reading glasses because when things are right in front of their face, their eyes are trying to pull to the correct shape of lens, and it's just not working. The other accommodation that you can't really control, your eye adjusts itself for brightness. When you go outside and it's too bright, your irises are going to close up. They're going to make the pupil really tiny, because the goal is it doesn't want to let in too much light that could damage the retina.